Hello everyone, I am Shankha Subra Sanyal and I welcome you all on behalf of S-Cube's classes. Well, I'm really thankful to all of you for your overwhelming response. The amount of love that you have shown through your mails, through your feedbacks, I'm really grateful. I'm really privileged. Well, we begin this session with a discussion on fundamental theorem of arithmetic. We know that a prime number has exactly two factors, while a composite number has more than two factors. The fundamental theorem of arithmetic. Let's see what does it say. It says every composite number can be uniquely expressed as a product of primes except for the order in which this prime factor occurs. This will become more clear when we go through the few examples given on the screen. Suppose we need to find the prime factors of 105. So if I go by the prime factorization method, I find that the prime factors of 105 is 3, 5 and 7. Similarly, that of 462 is 2, 3, 7 and 11, and that of 651 is 3, 7 and 31. Let us simplify each of the following and show that the result is a composite number. We are given the first question as 5 into 11 into 13 plus 13. If you check this question, 13 appears as a common term. So if I take 13 common out of it, so I'm left with 5 into 11 plus 1 once I take 13 common out of it. So what am I left with? I'm left with 13 into 56. So check over here if 56 can be broken down into the factors 7 and 8. Thus the given number has more than two factors. Thus it is a composite number. Let's take another example, the second one. 6 into 5 into 4 into 3 into 2 into 1 plus 5. Now over here the term 5 can be taken as common. So I can write this as 6 into 4 into 3 into 2 into 1 plus 1, which the entire thing is multiplied by 5. We get it as 5 into 145, which is nothing but 25 into 29. Now see, the given number has 1, 5 and 29 as factors. So again, it is a composite number. Let us find the HCF and LCM of 612 and 1314 using prime factorization method. So we have this tree approach that we have. 612 can be written as 2 into 306, while again 306 can be written as 2 into 153, while 153 can be written as 3 into 51, while 51 can again be further subdivided into the factors 3 and 17. So 612 are having the factors 2, 2, 3, 3 and 17. That simply means 2 square into 3 square into 17. Now if I am supposed to take out the factors of 13, 14, that is 1314, similarly we'll be getting the factors to be 2 into 3 cube into 73. Now the HCF of 612 and 314 is the product of the common terms with lowest powers. So what do I have? I have 2 into 3 square, or simply 18. While the LCM of 612 and 314 is the product of prime factors with highest powers. Now how much is that? 2 square into 3 square into 17 into 73, which the product comes up to 44,676. So what do we find? HCF is 18 and the LCM is 44,676. From the last two examples that we discussed, we have some results on HCF and LCM. The product of HCM and LCM, if I write that as product of two given numbers, then HCF divides LCM completely, leaving no remainder. Let's take this example. The HCF of two numbers is 116 and their LCM is 1740. If one number is 580, let's find the other number. This was a question that came in 2019, very recently. So, as I have just said, the product of the two numbers is equal to HCF into the LCM. So, let us consider the other number to be x. So, 580 into x is 116 into 1740. So, this leaves us with the value of x, or the second number, to be 348. Let us take another example. It is given that HCF of 252 and 594 is 18, while we are asked to find the LCM of the numbers. See the two numbers that are given to us and also the HCF. So what we are left with? We are just left with putting them in the formula. So the LCM into HCF is the product of two given numbers. So LCM is 252 into 594 divided by 18, which is nothing but 8316. This is a question which is based on the same formula, but it's a little twisted. It says, find the simplest form of 148 by 185. Actually, what it's trying to say is 185 by 148, we try to find the HCF of it. And how much do we find? It is 37 on division. So, on dividing the numerator and denominator, we get a fraction 37. So, if I divide both the numbers by the same HCF that we have got, we would be getting the simplest form. And what is the simplest form? It's 4 by 5. In this question, we are asked to find the HCF and LCM of 108, 120 and 252 using prime factorization method. Now, if I go by the prime factorization method, what do I get? I get 108 to be having the factors 2, 2, 3, 3 and 3, which simply means 2 cube into 3 cube. Similarly, for 120 would be getting 2 cube into 3 into 5. And for 252 we'll be getting 2 square into 3 square into 7. Now see, the HCF of 108, 120 and 252 actually means the product of the common terms with the lowest power. Just check the screen. You would find that the lowest power for 2 is 2 square, while that for 3 is 3 to the power 1. We don't have anything common for all three in 5 and 7. So my answer to this is the HCF of 108, 120 and 252 is 12. While we are talking about the LCM, we actually talk about the product of prime factors with highest powers. So what are the highest powers of 2, 3, 5 and 7? It's 2 cube, 3 cube, 5 and 7. So the LCM over here is 7560. Similarly, if we take another question where we are asked to find the largest number which divides 245 and 1037, leaving remainder 5 in each case. Since a remainder 5 is left over, that means I need to subtract 5 from either of the number, from the both the numbers to get the number which is divisible. So what do we get? 245 minus 5 is 240, while 1037 minus 5 is 1032. Now, if I find the HCF of these two numbers, I know that this is the number which is the required number. So how do I find that? I simply go by the prime factorization method and I find that 240's factors are 2 to the power 4, 3 and 5, while that of 1032 is 2 cube, 3 and 43. If you check, HCF means the lowest power, and we find that 2 cube and 3 comes up meeting our requirements. So the required number is nothing but 24. Let's now consider this question. It is something similar to the last question that we have discussed. Find the largest number that will divide 398, 436 and 542, leaving remainders 7, 11 and 15 respectively. Again, if you check on with this question, you would find that it actually talks about leaving a remainder means we have to subtract these values from the respective numbers. So 398 minus 7 gives us 391, while 436 minus 11 gives us 425, while 542 minus 15 gives us 527. That means these numbers, if I take a HCF of these, I would be getting the required number. And what do I find? I find 391 gives me 17 into 23. 425 gives me 25 into 17, while 527 gives me 17 into 31. So I find 17 is a common factor for all these numbers. So what is my required number? I mean the HCF. The HCF is 17. So my required number is 17. The next question is on your screen. It says two tanks contain 504 and 735 liters of milk respectively. Find the maximum capacity of a container which can measure the milk of either tank an exact number of times. Now, since it is talking about maximum, that gives us a hint that we are trying to talk about HCF, means highest common factor. So on resolving the numbers given to us 504 and 735 into its prime factors, we get 2 cube, 3 square and 7 as the factors for 504, and 5, 3 and 7 square as the factors of 735. So that leaves us with the HCF to be 21. So the capacity of the required container is nothing but 21 liters. Let's take this question. An army contingent of 612 members is to march behind an army band of 48 members in a parade. The two groups are to march in the same number of columns. What is the maximum number of columns in which they can march? Mark the word again, maximum. It gives us a hint. Actually, we need to find the HCF. And what do I find? Once I do the prime factorization of these two numbers 612 and 48, I find that the HCF of these two numbers is 12. So the required number of columns is nothing but 12. A sweet seller has 420 Kaju burfis and 150 Badam burfis. Guys, focus on the question, not on the burfis. Well, he wants to stack them in such a way that each stack has the same number and they take up the least area of the tray. How many of these can be placed in each stack? How many stacks are to be formed? Now again, maximum number of burfis is given. That is, we need to find out the HCF. And what are the HCFs? What is the HCF of these two numbers? We get it to be 30. Now maximum number of burfis in each stack that can be kept is 30. So number of stacks is 420 divided by 30 plus 150 divided by 30. That gives me what? That gives me 19. So there would be total 19 number of stacks. On a morning walk, 3 persons step out together and their steps measure 30 centimeter, 36 centimeter and 40 centimeter respectively. What is the minimum distance each should walk so that each can cover the same distance incomplete steps. Now check over here, the word is given as least or the minimum. So once the word minimum comes in, we are asked to find out the LCM. So what we do? We find the LCM over here. Required distance is the LCM of 30, 36 and 40 centimeter. So what do we find? We find the required distance to be 360 centimeter. Hence, we can say the answer to this question is 360 centimeter. This question actually came in 2019. Let's take this question. Ravi and Shikha drive around a circular sports field. Ravi takes 16 minutes to take one round, while Shikha completes the round in 20 minutes. If both start from the same point at the same time and go in the same direction, after how much time will they meet at the same point? Check. No word has been given over here that gives me a hint, but over here, since it's the time that has to be measured and they will be coming down to the same point, we are supposed to use the LCM. We are supposed to find out the LCM. So if I take the LCM of 16 and 20, I find that the LCM of these two numbers is 80. Hence, both will meet at the starting point after 80 minutes. Well, remember, either they will be giving a hint of maximum, minimum. They might not be giving the hint even, but you have to understand the question to solve it. In a school, there are two sections, namely A and B of class 10th. There are 30 students in section A and 28 students in section B. Find the minimum number of books required for their class library so that they can be distributed equally among students of section A and section B. Check out with the word. Again, a hint has been given to you that you simply need to find the LCM because the word minimum has been used over there. So if I find the minimum, that is the LCM of 30 and 28, what do I find? I find the value to be 420. Hence, the required number of books is 420. Let us take this penultimate question. Show that any number of the form 4 to the power n, where n belongs to natural number capital N, can never end with the digit 0. If 4 to the power ends with 0, then it must have 5 as a factor, because we know anything that ends with 0 must be having 5 as a factor. But 4 to the power n is nothing but 2 square to the power n, which is 2 to the power 2n, shows that 2 is the only prime factor of 2 to the power n. Also, we know from the fundamental theorem of arithmetic that the prime factorization of each number is unique. So 5 is not a factor of 4 to the power n. Hence, 4 to the power n can never end with the digit 0. In fact, this kind of questions you'll be finding when you'll be going down for competitive exams when you pass out your class 12th or maybe graduation. The exams that are there, the SSC level exams, you'll be finding this kind of questions. So please mark my words. Look out for this question seriously. Let us take this last question. It says that show that any number of the form 6 to the power n, where n belongs to natural number capital N, can never end with a digit 0. If 6 to the power n ends with 0, then it must have 5 as a factor, as I explained in the last question. But 6 to the power n is nothing but 2 into 3 to the power whole to the power n. That actually means it has 2 and 3 as the prime factors of 6. Also, we know from the fundamental theorem of arithmetic that the prime factorization of each number is unique. So 5 is not a factor of 6 to the power n. Thus, 6 to the power n can never end with the digit 0. So this brings us to the end of the lecture. Well, before I sign off, as I always do, I would request you, in case you have any queries, please do feel free to write to me at scubesclasses@gmail.com, or you can WhatsApp me on the numbers given on your screen. It would be a privilege on my part to be addressing your queries. Thank you so much.